Bismillahirrahmanirrahim. Assalamu alaikum, students. How are you all? I hope all of you are fine. I'm your chemistry teacher. Today's our topic is about numericals of the chapter number 2. Uh, Numerical is defined as expressed as a number, or it's a way to express in a number. So, or if we can say the list are in numerical order. In numericals, we have in three steps. Number one, data, solution, and result or answer. In data, what things are given in your problem or numerical, we will write and what we have to find there. Then in solution, we will apply formula and how to solve it. And in result and answer, finally, you will get the solution that is your result or your answer. Now, first numerical of your book is on page number 39, numerical number 11. The atomic mass of a chlorine L35 and Cl37. Cl35 having 75% and Cl37 have 25%. Chlorine 35 and chlorine 37 are the two isotopes of a chlorine. That's why if having the atomic mass 35 and second one having 37. And their atomic masses are given in the form of a ratios. That is a 75% ratio and 25% ratio. Now task is to calculate the average atomic mass of a chlorine. So number one step, data, in which we will write what are given in our problem. Number one step, atomic mass of a Cl35 is 35 AMU. Second step, the atomic mass of a chlorine Cl37 is 37 AMU. This is two things that are given in your problem. And now for percentages of a chlorine C35 is a 75 is given in above in your numerical, and next one is a percentage of a 37 is a 25%. So these things are given in your numerical. Now next step is your task to find out the average atomic mass. This is your data. Now next step is a solution. In solution, first we will find out the atomic mass of a chlorine. Atomic mass of a chlorine is a Cl35. So it is given in a form of a percentage. So it is a 75 over 100 and multiply by this 35. So we will get the 26.25. After the calculation, we will get this. Number two, the atomic mass of a chlorine 37 is given 25%. 25% means it is 25 over 100 and multiply by given 37. So then after this calculation, dividing 25, multiplying 25, multiply by 37, dividing 100, we will get 9.25. So now next step, the average atomic mass of a chlorine. How we will get the average? Average means total. Total atomic mass or the weight are the same thing. Weight of the chlorine is by adding we can get 26.25 is from Cl35 and 9.25 from a Cl37. When we add up both these, so then we will get 35.5 AMU. This is the answer of the first numerical, and you will make the box on the answer. It means you are highlighting your answer. This is your result, this is your answer. This is all about numerical number 11. So next numerical. This is your book problem number 12. How many atoms are there in 5 moles of a sulfur? In this numerical, 5 moles of sulfur are given. Our task is to find out the how many atoms are present in 5 moles. Now number one step, data. In data, the number of moles of SS is representing the sulfur, N is representing the number of moles, that is 5. Next step, Avogadro's number. As you know, Avogadro's is denoted by Na, and its value is constant for all elements, that is 6.02 10 raised to power 23. This value is a fixed for all elements. Now, what we will find? Number of atom in a 5 moles. Number of atoms in a 5 moles. This is our task. Now comes to the solution. In solution, we will use the unitary method. What is the unitary method? Unitary method is a technique for solving a problem by first finding the value of a single unit and then find the necessary value by multiplying the single unit value. Mean in primary classes you learn about if you know the price of one pencil, so you can easily find out the price of a 12 pencil, 13 pencil, and so on. So same in that manner we will do in this numerical. 1 mole of sulfur contains 6.010 raised to power 23 atom. I have already told you that values are fixed for all elements. Now step number 2, 5 moles are given. So in 1 mole that is a fixed 6.02. Then in 5 moles we will multiply 5 multiplied by 6.010 raised to power 23 atom and divided by 1. So 1 has none value not shown here. It doesn't mean here 1 is not present here. Then we will multiply 5 multiplied by 60.210 raised to power 23 atom. Then we will get 30.1 10 raised to power 23. Now now in this point we having a in scientific method, when we shift decimal from our right to left, then we convert into a power according to replacement. In this step we have shifted the decimal from right side, that is on 1, toward the 3. So shifting from one number, that's why we having the 10 having the power 1, and 10 raised to power 23 is the same. Then 3.01 multiplied by 10 is both having the same basis, 10 and 10. Then we get the 10 and adding their values 23 plus 1. Then we will get that 3 decimal 01 10 is to 24 atom. This is all about this numerical. We have find out with the help of unitary method. This is a unitary method by which we have find out the atoms of 5 moles of sulfur. Now, next numerical. This is your book numerical number 14. What is this numerical? What number of oxygen atoms are present in a 4 gram of oxygen? In this numerical, 4 grams of oxygen are given. Our task is to find out how many numbers of atoms of oxygen are present in 4 grams. So first we have in the data, mass of oxygen is given, that is a 4 gram. Molecular mass of oxygen is oxygen exists in a diatomic atomic state, mean is having 2 oxygen, mean O2. That's why the mass of oxygen is a 16 multiplied by 2, we will get the 32 gram. Now next step, Avogadro's number. I have already told you Avogadro's number denoted by Na, and its value is constant for all elements, that is the 6.02 10 raised to power 23. Now we have to find number of atoms in a 4 gram of oxygen. This is the task of the problem or the numerical. Now next step is a solution. Now here we will use the formula. The formula is a number of atoms is equal to Avogadro's number multiplied by mass of a substance divided by molecular mass. What is this? This is Avogadro's number divided multiplied by mass of substance divided by molecular. Now apply the values or you put the values. 6.02 10 raised to power 23 is a value of a Na. The mass of substance is a 4, that is a given, and divided by molecular mass of the oxygen is 32. Then 6.02 10 raised to power 23 multiplied by 4 and divided by 32, then we will get the 24.08 10 raised to power 23 atom, and then divided by 32. What will come? When we divide 24.08 multiplied by 10 raised to power 23 divided by 32, then we will get 0.7525 10 raised to power 23 atom. And we can simplify according to a scientific method. We will replace the decimal and 7.525 10 raised to power 22 atoms answer. Both answers are correct. You can write in this method or also in this method. So both way are correct to write in this form and in this form. So this is all about numerical number 14. Please students take a screenshot of each slide. Now next numerical. It is a numerical number 17 of your textbook. What is the mass in gram of a 1 multiplied by 10 raised to power 22? sodium in atoms. Now here, mass, we have to find the mass in gram, and given is 1 multiplied by 10 raised to power 20 sodium in atoms. Now data, first step data. Element is a sodium, that is Na. Atomic mass of sodium is 23 gram. This is not given in your numerical, but you learned the first 20 elements, atomic numbers as well as atomic masses. The number of atoms is given, that is a 1 multiplied by 10 raised to power 20. And then Avogadro's value, that is 6.02 10 raised to power 23. This is constant for all elements. Now we have our task is to find out the mass of sodium, that is Na is equal to question mark, that is we have to find out. Now solution. Now here we will apply the formula. Mass of substance is equal to atomic mass in grams multiplied by number of atoms divided by Avogadro's number. Now apply these values in the formula. Mass of a one atom of a sodium, atomic mass in gram is 23 gram, and number of atom is a 1 multiplied by 10 raised to power 20, and that is Avogadro's values there, that is a 6.0 to 10 raised to power 23. Then after the solution, then 23 10 raised to power 20 divided by 6.0 to 10 raised to 23. Now we will simplify. After multiplying 20, dividing the 23 divided by 6.02, we will get the 3.82, and bases are the same, the exponents are the subtracted, then we will get the minus 3. So our answer is 3.82 10 raised to power minus 3 gram, or we can write in a simplest form, that is 3.0. Now next problem. Problem number 22. First, what is the problem actually? The formula of a rust, Fe2O3. Formula of a rust, Fe2O3. How many moles of Fe are present in 30 gram of a rust? 33 gram, that is a mass of a rust is given. Task is to find out the moles of a iron. Now first, data. Formula of a rust, Fe2O3, this is already mentioned in the numerical. Amount of rust is a 30 gram, and moles of iron in the rust, that is a task, or we have to find out. Now solution. 160 gram of Fe2O3. From where 160 get? Fe having the atomic mass 56, and 2 atoms are used, so 56 multiplied by 2, we will get the 160, and 3 oxygen atoms are used, and 1 oxygen atom having atomic mass 16. When we will multiply 16 with the 3, then we will get 48. When 160 plus 48, then we will add both the terms, then we will get the 160. So 160 gram of Fe2O3 contain 112 gram of iron. In this formula, Fe2O3 total weight is 160 gram, and in which 112 gram is iron. Now again unitary method. 1 gram of Fe2O3 contain 112 divided by 160 of a gram of a iron. Now then in 30 gram we will find out 30 gram of a Fe2O3 contains 30 multiplied by 1 over 112 divided by 160 gram of iron. Means we know in a 1 gram, now we are finding in a 30 gram. So 30 gram of Fe2O contain 21 gram. When we will divide this whole term with the 160, then we will get the 21 gram of iron. Now next step is to find out the moles of Fe in Fe2O3. For this we having the formula mass in gram divided by molecular mass of iron. This is the formula, mass in gram divided by molecular mass of iron. So mass in gram is 21 and divided by 56. 56 is a molecular mass of a single Fe. Okay. Then we will divide both, then we will get the 0.375 mole. This is a moles of Fe in Fe2O3, that is a 0.375 mole answer. In this numerical, we use the two methods. One is a unitary method, then we apply the moles formula. Okay, and then at the end highlight your answer. So this numerical, in this numerical, two conditions are applied. We have applied. One is a unitary method, and second one is a related to the formula of a moles. Now next numerical of your textbook or exercise page, that is a 33. Consider the combination of a carbon monoxide with oxygen gas. The carbon monoxide and oxygen are reacting together. It will form the carbon dioxide. Calculate the numbers of moles of a carbon dioxide produced when 50 gram moles of oxygen are reacted with all carbon. Means carbon monoxide and oxygen are reacting, and oxygen are using 50 moles of having the 50 moles, and now our task is to find out the number of moles of a carbon dioxide is produced. Now first step, data. Number of moles of oxygen that is given is a 50 moles. MOL is a short form of a moles. Number of moles of a carbon dioxide is we have to find out. Now solution. Number one. First we having the equation. Two carbon monoxide molecule reacting with the oxygen form the two carbon dioxide molecules. So in terms of a mole, another way we have to write with the help of a coefficient. What is a coefficient? By the number which we are balancing the chemical equation is known as a coefficient. So oxygen is balanced with a no number, it's mean that is a 1. Carbon dioxide is a balancing with a 2, it's mean having the 2. Oxygen having 1 mole and carbon dioxide having 2 mole. Or all the carbon monoxide is consumed, that's why we are not using carbon monoxide, only we are using oxygen and carbon dioxide. Now next step, again unitary method. 1 mole of oxygen produces 2 mole of carbon dioxide. This is a proof from the above equation. 1 mole of oxygen and 2 mole of carbon dioxide. Now next step, in 50 moles are given in a problem. The 50 moles of oxygen will produce, we will multiply by 2 with the 50 and divided by 1, then we will get 100 moles of carbon dioxide. We are using unitary method. Now next step, number of moles of carbon dioxide is 100 moles. Then this is all about this numerical. In this numerical, we use the unitary method in which we know the moles. 1 moles of oxygen producing 2 moles. Then we have find in 50 moles of 50 moles of oxygen. That will answer will come 100. Now next numerical. This is problem number 34 in your textbook exercise. Calcium carbonate. On heating give the calcium oxide CO and carbon dioxide gas. That is calcium carbonate on heating give the calcium oxide and carbon dioxide. Calculate how many grams of calcium oxide CO can be obtained by heating 8 moles of our calcium carbonate. Same numerical like a previous one, but that numerical moles are used, but here we are using in terms of a gram. Now data. Numbers of moles of calcium carbonate is 8 moles. That is a given. Total mass of a calcium oxide we have to find out. Now solution. Molecular mass of a calcium. In this case, calcium oxide CaO, 1 calcium plus 1 oxygen is 2. So 1 multiplied by atomic mass of a calcium, that is a 41, and atomic mass of oxygen is a 60. That 1 multiplied by 40 plus 1 multiplied by 60, that will come 40 plus 60. Then after adding, we will get the 56 gram. Now next step. Continuing the same problem, now we will apply the unitary method. 1 mole of calcium carbonate give 56 gram of calcium oxide. By then, in 8 moles of a calcium carbonate will give 8 multiplied by 56 divided by 1 of a calcium oxide, we will get the 448 gram of a calcium oxide. Now, 8 moles in 8 moles of a calcium carbonate, we will get the 448 gram of a calcium oxide. So, total mass of a calcium oxide is 440 gram of 448 gram. This is your answer, and highlight this answer by making the box. Now, next numerical. Numerical number 35 in the textbook. Silicon tetrachloride can be prepared by heating silicon in a chlorine gas. Silicon plus 2Cl2 HCl4, then we will get the silicon tetrachloride. Now, how many moles we want to prepare? 10 moles of a silicon tetrachloride of a molecular chlorine will be used in this reaction. In this, the task is to find out the moles, how many moles is used in this reaction. So 10 moles of a silicon tetrachloride is given. Now, data, moles of a silicon tetrachloride, that is SiCl4, is 10 ml. That is given in your problem. Moles of a chlorine, that is the question mark, we will find out. Now, solution. Now, equation. Now, consider this equation. Silicon plus 2Cl2 plus, get the SiCl4, and 2 moles of chlorine are used and 1 mole of a silicon tetrachloride is used. So, 1 mole of a SiCl4 requires 2 moles of a chlorine. It is proved with the help of a equation. So, look at the equation again. 2 moles of chlorine are consumed by a silicon to form the silicon tetrachloride. So 2 moles of a chlorine and 1 mole of a SiCl4. So 1 mole of a SiCl4 requires 2 moles of a chlorine. Now, next step. 10 moles of a silicon and tetrachloride will require. So how we will do? 2 multiply by 10 divided by 1 of a moles of a Cl4. Now, 10 moles of a SiCl4 we will require 20 moles of a chlorine. Then number of a moles of chlorine is 20. That is our answer. So this numerical is same as the previous one. Now, next problem number 36. Fermentation is a chemical decomposition in which glucose C6H12O6 is converted into ethyl alcohol C2H5OH and carbon dioxide. Fermentation is a chemical decomposition process. What is the decomposition? Breaking down of a single substance into a 2 or more substance. So, fermentation of in which the glucose converted to ethyl alcohol and the carbon dioxide. Now, next, look at this in the form of equation. That is a formula of a glucose C6H12O6. When decomposed in the presence of heat, it will give the C2H5OH, that is a ethyl alcohol and the carbon dioxide. Now, what will be the amount of ethyl alcohol in grams and the mole? Our task is to find out the mass in grams and the moles of ethyl alcohol, which can be obtained by the fermentation of a 5000 gram glucose. Means fermentation occur in a glucose, its mass is 5000 gram. Now our task to find out the grams of ethyl alcohol as well as its moles. First data, amount of glucose is 5000 gram. Moles of ethyl alcohol not given. Amount of ethyl alcohol not given. We have to find out some solution. According to our equation, 1 mole of glucose is used, 2 mole of ethyl alcohol and 2 mole of carbon dioxide are used. 1 mole of C6H12O6 mean glucose is 6 carbon atom are present and multiply by atomic mass of a carbon. 12 hydrogen are present, atom are present, multiply by atomic mass of a hydrogen, and 6 oxygen atom are present, multiply by atomic mass of oxygen. Now, 12 is atomic mass of a carbon, 6 multiplied by 12 plus 12 multiplied by 1 is atomic mass of a hydrogen plus 6 multiplied by 16, 16 is atomic mass of a oxygen. When we will solve this whole, then we will get 6 multiplied by 12, 72 plus 12 multiplied by 1, 12, 6 multiplied by 16, we will get the 96. When we add 72 plus 12 plus 96, we will get 180 gram, that is a molecular mass of a glucose. 1 mole of a glucose contains 180 gram molecular mass. Okay, then next step, now 1 mole of a C2H5OH. C2H5OH, what is this? It's a formula of ethyl alcohol. So again we are doing the same thing like the glucose. 2 carbon atom are present, so 2 multiplied by C, 5 hydrogen are present, 5 multiplied by hydrogen, 1 oxygen is present, 1 multiplied by oxygen plus 1 hydrogen is present, so 1 multiplied by hydrogen. Now 2 multiplied by 12, 12 means it's atomic mass of a carbon plus 5 multiplied by 1 is atomic mass of a hydrogen, 1 multiplied by 16, 16 is atomic mass of oxygen, 1 multiplied by 1 is atomic mass of a hydrogen. So when we will multiply and add this, we will get 2 multiplied by 12, we will get the 24 plus 5 multiplied by 1, we will get the 5. 1 multiplied by 16, we will get the 16. And 1 multiplied by 1, we will get the 1. Now, when we add 24 plus 5 plus 16 plus 1, we will get the 46 gram molecular mass of ethyl alcohol. Now, next step, 2 moles of a C2H5O contain, now this 46 multiplied by 2. Why we are multiplying with the 2? Because 2 moles of C2H5OH are produced. Now, when we multiply 2 multiplied by 46 gram, then we will get the 92 gram. Now, next step, 180 gram of a glucose gives the 92 gram of a ethyl alcohol. 180 gram of glucose will give the 92 gram of ethyl alcohol. This is 180. From where we will get the 180? 180 is the molecular mass of a glucose, and only 2 moles of a ethyl alcohol are produced. That's why we are having the 92 gram of a ethyl alcohol. Now, next step. Now we are again using the unitary method. In unitary method, 1 gram of glucose will give 92 divided by 180 and of a ethyl alcohol. Then we will get in 5000 gram. Now our task is to find out in a 5000. 5000 multiplied by 92 divided by 180 of ethyl alcohol. Then we will get 25. 55.55. This is ethyl alcohol mass in 5000 gram. Now, amount of ethyl alcohol is 25, 5, or in other words, we can say 2,555 decimal 5. Now, moles. Now, next task is to find the moles of a ethyl alcohol. Amount of a mass of ethyl alcohol divided by molecular mass. Now apply the values. 2,555 divided by 46. Then we will get 55.55 mole. This is our answer. This is all about this numerical. Now next is a home assignment. Now we have covered the chapter number 2. All questions we have already given in your previous classes, that are the state the law of a conservation of a mass, state the law of a constant composition, explain law of a multiple proportion with example, explain law of the reciprocal proportion with example, Define the following terms: atomic mass, molecular formula mass, empirical formula, molar mass, mole, Avogadro's number formula. This is previous task, but now new task is here to complete the blanks and MCQs on page 37 and 38 in book, and also complete the questions of a page 38 to 40 in copy. So, and figure out these numerical in your